Have you ever stopped and wondered how an AI like ChatGPT actually works? How it goes from, well, basically nothing to a powerful assistant that can write code, whip up a poem, or answer your most random questions. Today, we're going to pull back the curtain and demystify exactly how a large language model, an LLM, really learns. Okay, let's get into it. We're essentially going to follow the entire life story of an LLM. We'll start at its birth with the Transformer blueprint, then follow it through its university years where it reads pretty much the whole internet. From there, we'll see how it gets specialized training to become an assistant, and finally, we'll take a peek at what the future holds.
So, first things first, we have to tackle what it even means for an AI to learn. Because I'll tell you right now, when we say an LLM is learning, it's probably not what you're imagining.
I mean, when you interact with an AI, it feels like it's thinking, right? Maybe it even feels like it understands you. But is that what's really happening under the hood? Well, not really. See, human learning involves consciousness, real-world experience, and a genuine understanding of abstract ideas. LLM learning, on the other hand, is a colossal mathematical process. It's all about adjusting billions, and I mean billions, of internal numbers or parameters to find statistical patterns in data. It is pure optimization, not deep contemplation. And what is this gigantic optimization process for? You might be surprised. It all boils down to one deceptively simple goal: predict the next word. The model sees a phrase like "Mary had a little," and its entire, incredibly complex structure is fine-tuned to increase the odds that it will predict the word lamb. That's it. That one simple task, repeated trillions of times, is the engine that drives everything else. And this, right here, is the most fascinating part. The intelligence we perceive isn't programmed into it directly. It's an emergent property. Just by getting insanely good at predicting the next word, the model is forced to learn about grammar, facts about the world, and even basic patterns of reasoning. It all just emerges.
So, how does a model get that good at that one simple task? The secret is in its design, and that leads us right into Section 2, the Transformer blueprint. This is the revolutionary architecture that absolutely changed the game.
You know, before the Transformer came along, we had models like RNNs. And their biggest problem was they had to read words one by one, in a sequence. This was painfully slow. And worse, they'd often forget the beginning of a long sentence by the time they got to the end. It was a huge bottleneck holding everything back. The massive breakthrough was a mechanism called self-attention. This brilliant idea allows the model to look at all the words in a sentence at the same time and figure out which words are most important for understanding the context of any other single word. No more processing one by one. It's a total paradigm shift. The best way to understand self-attention is with an analogy you use every day: a search engine. Think of each word in a sentence running its own little search. It sends out a query, which is basically asking, hey, who in this sentence is relevant to me? It then compares that query against the keys from all the other words, which act like little titles advertising their meaning. When it finds the most relevant keys, it pulls in their values, which is their actual, meaty, contextual information. This all happens in 4 key steps. First, the model calculates a score by comparing one word's query to every other word's key. Then, those scores are scaled down just to keep the math stable. Next, a function called softmax turns those scores into nice, clean probabilities. We call these attention weights. And finally, it creates a brand new context-rich representation for the original word by blending the values from all the other words using those attention weights as a guide. Okay, with that powerful architecture in place, the model is finally ready for the most intense and expensive part of its life. Welcome to Section 3, Pre-Training University. This is where it builds its foundational knowledge by reading the entire internet. The learning process here is called self-supervised, which is super clever. It means no human has to sit there and label all the data. The model just takes a sentence, hides the last word, and tries to guess what it is. The text itself provides the correct answer, so it's its own answer key. This is an incredibly efficient way to learn from trillions of words of raw, unstructured text. And there's that idea of emergence again. To get better at that one simple task, predicting the next word, the model is forced to build an incredibly complex internal map of reality. It has to implicitly figure out grammar, what words actually mean, tons of facts about the world, and even patterns of logic and reasoning. So, After pre-training, what we have is basically a very knowledgeable text completion engine. It's not really a helpful assistant yet. So how do we get it there? That's what Section 4 is all about. From predictor to assistant, where the model gets its specialized training. This journey from generalist to specialist happens in distinct stages. It starts with that massive general pre-training on unlabeled text. Then it goes through supervised fine-tuning, or SFT, using a much smaller, high-quality dataset of conversations to learn how to follow instructions. And finally, it's refined with reinforcement learning from human feedback, or RLHF, to align its behavior with what we humans actually find helpful and safe. Now, the traditional way of fine-tuning had some big problems. For one, updating all those billions of parameters every time is incredibly expensive. And even worse, it can lead to something called catastrophic forgetting, where the model basically overwrites its vast general knowledge while learning a new specific skill. Not good. The solution is a really elegant technique called parameter efficient fine-tuning, or PEFT. Methods like LoRA freeze the huge original model and just train a small set of new adapter layers right on top. This makes specialization way cheaper, and crucially, it preserves the model's core knowledge so it doesn't forget everything it learned in university. That final alignment step, RLHF, is a fascinating process. It starts with humans ranking different AI-generated answers to a prompt, from best to worst. That data is then used to train a totally separate reward model, whose only job is to get good at predicting what kind of answers humans will like. Finally, the main LLM is fine-tuned with a new goal: generate answers that get the highest possible score from that reward model. That's how it learns to be helpful and harmless. Now, this entire learning process, as powerful as it is, comes with some built-in inherent limitations. And that brings us to Section 5, the boundaries of knowledge. These aren't just random bugs. They are a direct result of how these models learn. Hallucinations happen because the model is a probability engine, not a fact checker. We've already talked about catastrophic forgetting. Bias amplification happens when it learns and then parrots back the ugly stereotypes it found in its internet training data. And a huge future risk is model collapse, where AI learning from other AI-generated text could create a weird, degenerative feedback loop of garbage in, garbage out. So, with all those pretty serious challenges in mind, where do we possibly go from here? That brings us to our final section, the next chapter, and how the entire field is evolving to build better, smarter, and safer models. This whole learning process has gotten us incredibly far, but its limits are becoming crystal clear. The goal now isn't just about building bigger and bigger models, but about building more reliable and trustworthy ones. But this leaves us with a critical and kind of scary question for the future. What happens when the next generation of AI learns from an internet that's filled with text written by the last generation of AI? That is the puzzle that's going to define the next chapter of this incredible story.